Alright, so we are at the last video of CK 2025 series. This is day 55. So we have added close to 13 videos on top of what we had earlier in 40 days of CK series. It's because all the recent changes that happened this year in 2025. So I know it took a long time that I expected and then I promised, but I had to make sure that I cover everything from the exam perspective, cover all the important tasks and hands-on that they are asking these days in the newest exam curriculum. So with that being said, if you are new here, my name is Piyush and this is the last video of CK 2025 series. So do not start from this video if you are new to Kubernetes or if you are preparing for CK. Make sure you follow in the same sequence from day 0 video onwards. Okay. In this video, we'll be setting up multiple master, multiple control planes, multiple worker nodes, load balancer to make sure that our Kubernetes cluster is highly available. This could be viewed as a extension to day 27. In day 27, we had set up multiple worker nodes, but a single master. But in this video, we'll be setting up multiple master nodes as well. Okay, so yeah, so let's start the video. But before that, just wanted to remind you, if you have not subscribed the channel, there's a subscribe button over there. I'm sure you can do that. You can just click that to support the channel like you have always done. Gives it a thumbs up if you like the content, and yeah, keep supporting. So let's go. So let me just share my screen, and this is what we did in day 27, right? We had multiple worker nodes, as you can see, and one control plane or master node. But there were some issues with that, right? It is highly available, but from workload perspective, but from worker node perspective, even if this node goes down, let's say, we still have two more nodes. And if this like two nodes go down, then we have the third node um, to host the workload and users might not be impacted. But what happens when this control plane goes down? It only has one node. That means it is running on a single server. What if that single node goes down? Your all the administrative functions will not work. Okay, your existing pod will continue to run because they are hosted over here. There is a container runtime, there is kubelet, they'll take care of that. But what will be the impact of the control plane failure? Let's understand. Control plane have these components. Okay, so we have API server, which is the entry to all the incoming requests and which is considered as the heart of the control plane or the master node. Now, whenever you run any kubectl command, it won't work because API server is down. Scheduler is responsible for scheduling incoming pods to one of the available nodes. So that means any new pod, if you try to create a new pod, or if you, let's say, try to schedule a new pod, or if it is in pending status, it won't be able to schedule in one of these nodes because scheduler is down. Controller manager, which has a lot of controllers like node controller, namespace controller, it has deployment controller, replica set controller, and so on. It is responsible for making sure that your Kubernetes object has like the desired state is equal to the actual state. For example, deployment controller make sure that the number of replicas should be always up and running, or the node controller make sure that if the node is unhealthy, it try to like it will pause the message that it is in not ready status, and it will try to restart the node as well, like in a managed cloud environment and so on. There are other controllers like replica set controller, there is namespace controller, and so on. There are many other controllers, so those functions will also not work. HCD, which is a key value data store, which stores the current state of the cluster, all the configuration, all the objects, status, state, everything is stored over here. So that means, let's say, when like if you want to retrieve an information from the cluster, or if you want to create a new pod, if you want to create a new service, it won't be able to update that in the HCD database because like all these components are down. So that is the impact if there is a control plane failure. So overall, User is not impacted in the real time, but they will face a lot of issues, right? Like if any of the pods go down, if there is a container crash, there won't be any controller manager to restart it, or to add the new pods to the deployment or to the replica set, right? So how we can avoid this? So this is a single point of failure for control plane. How we can avoid this? We can avoid this by having multiple control plane nodes, like we had multiple worker nodes. Okay, so we have multiple control plane nodes over here. So this is the setup that we'll be implementing in this video. We'll be doing end-to-end demo of it. So we have multiple control plane nodes. As you can see, we have two control plane nodes and two worker nodes. You can have three. Like the best practice is to have like the odd number of nodes, because it helps with the network segmentation. If there is a network segmentation happen, it divides that node among multiple segments, right? But for the demo, otherwise the video will be 2 hour long. But for that is why for the demo, we have two control plane nodes, two worker nodes, and one node in which we'll be configuring the load balancer. Again, this load balancer will be also a single point of failure, because if this node goes down, then you won't be able to reach control plane, right? The master nodes. But like ideally you can just directly run the command against master node if this goes down, right? So in a way it's a little bit of hacky way of doing it, but it still works. um the other way of doing it, to have this load balancer as a managed service, so that it has multiple replicas running, and it will take care of like auto healing. It will take care of the auto crash of load balancer node and so on, right? It could go behind an auto scaling group and so on. Like there are multiple ways of doing that, but I'm not gonna get into in depth of that, because we are focusing on the Kubernetes installation, upgrade, administration from the CK exam perspective. So for that, this would be more than sufficient. Okay. So how does it work? Instead of issuing commands against the API server or the master node, the client or the user will issue the command against load balancer. This load balancer IP will be exposed to the client or to the users. So you run the command, and then load balancer will redirect that request, that API call or that request among multiple control plane or master nodes, as you can see over here. And the same way, load balancer will also receive the incoming request from the worker nodes and then redirect it to the multiple control plane. So in a way, load balancer will act as a mediator between user, worker nodes, and control plane nodes. Okay, so every request will go through this load balancer. Okay, and why do we actually need it? Because let's say if we don't have it, how would you manage the load between multiple masters? How will you make sure that we have highly availability of multiple master nodes, right? There is no other way of doing it. This is one of the setups. So we have, so this is called, I haven't written it over here, so let me just write it down. This is called stacked etcd. Okay, so this is stacked etcd, in which the etcd is part of the control plane node along with the API server and other component. There is another one, and it's called external etcd. Okay, in external etcd setup, what we have is we have separate nodes for etcd server for high availability. Like it further provides you more highly available cluster by separating etcd component from the control plane. Okay, so but we are not going to discuss that in this video. We'll be working on stacked etcd setup. Okay, this is called stacked etcd. Now like in this case, in this scenario, like we discussed, what will happen if the control plane node goes down in the previous setup over here. Now what will happen over here if one of these control plane node goes down? Let's say this one, if it goes down, then we have the other nodes other control plane node which will serve the traffic and which will do all these functions of API server, scheduler, controller, manager, HCD, and so on, right? So your administrative functions of the cluster would not be impacted. And usually we have at least 3 control plane nodes, even in case of a managed cloud service, or even if you set up a production environment. So we have at least 3 master nodes, and worker nodes depends on your use case. Okay. So this is what we'll be doing. This setup is similar to what we have followed in day 27 video. In day 27, we followed the step on one master node and couple of worker nodes, but there are some extra steps. For example, we'll start with, okay, first we'll set up 5 VMs on cloud, and you can use any cloud, or you can use a local virtual machine, like a local virtualization software as well, to create 5 virtual machines on your local desktop, whatever you're using. So we are using 5, 2 for master, 2 for worker nodes, and 1 for load balancer node. Then we'll configure all the networking things so that they can communicate between each other. We'll open the required ports for control plane worker nodes and for load balancer, and then we'll perform these steps. So these steps over here, so these are similar to what we have followed in day 27. We'll start with disabling the swap, then we'll update some kernel parameters, we'll install container runtime, run CNI plugin, and then install kubeadm, kubelet, kubectl. Pretty standard. Like, the different step that we'll be doing is we'll be initializing control plane over here on the master node 1. So we have 2 master node, right? So one master node will be acting as a leader node. Okay, so it's, master of master, or you can call it super master or leader master, whatever you want to call it, right? So we have 2 master nodes. This is master 1, master 2, but one of these nodes will act as a leader master node. Okay, in the leader master node, we will initialize the control plane using kubeadm init command, and then it will generate a couple of token for us. One token is specifically for other master to join this, and other token will be for the worker node to join this master. Okay, so like on the worker nodes, we will use the worker node token, and on the other master node, we will use the master node token. And on the load balancer, we'll install HA proxy. HA proxy is one of the open source load balancer that we'll be using. You can use anything if you have access to, let's say, there is MetaLB, and there are other load balancers. Feel free to use anything that you want. Then we configure it so that it will receive the incoming request from the front end and redirect it to the back end. So we will configure the configuration file of HA proxy with front end and back end details. Then we'll restart to make the changes into effect. Okay, so these are all the steps that we'll be following. All right, so let's go ahead and let me just take a sip. Okay, so I'm in my AWS console. Again, feel free to use any cloud you want. First step, I'll start with configuring VPC. I'm gonna create a new VPC. So create VPC and VPC and more. So let's give it a name. No, I don't want auto generated. Oh, okay. Let's give it a name. CK demo. Okay. I'm gonna start with the default CIDR. That's okay. And 2 availability zones. Okay, 2 public subnets, and I don't want private subnet, because if you configure private subnet, then you have to add NAT gateway as well, so that it will be able to install all the required packages and updates. So for the sake of simplicity, I'm gonna go ahead with the public subnet. Private subnet by default don't have access to the internet. Okay, and let's see what we have. Let's keep it the way it is. So we have 2 subnets over here. No, I don't need a NAT gateway. Okay, I think this should be good. So we have one VPC. It has 2 subnets and 1 route table. Then this route table has the access to internet gateway. Okay, so that's what we need. And let's hit create VPC. Okay, that's step 1. Now we'll be configuring security group, three security group, one for master, one for load balancer, and one for worker node. Okay. So I'm gonna start with, okay, let's hit view VPC and go to security groups. Let's create the first security group for master. Call it master SG. Okay, and security group for master node. Select the VPC, which is this one. Add inbound rule. So we have to add the inbound rule for each of the component. Okay, so we'll start with the Kube API server. So Kube API server listen on port 6443, and the source, you can add the source as your VPC CIDR, which is 10.0.0.0/16. Okay, in the description I'll add Kube API server. Then add the rule for inbound rule for Kube scheduler. Kube scheduler listen on port 10259 by default, and again the same thing, 10.0.0.16. Let's give it the name Kube scheduler. The next one is 10250, which is for kubelet, 10.0.0/16 kubelet. The next one is, okay, let me check if it is recording. Yeah. The next one is Kube controller manager, which is 10257, I believe. 10.0.0.0. Okay, and Kube controller manager. Okay, and then the last one for HCD. So 2379 to 2380. So I'm adding the port range because we have two master server. That means we have two HCD. So this is the range. One HCD will be using this port, another HCD will be using this port. So 10.0.0.0. So this is to have the connectivity between Kube API server and HCD. And then finally we need SSH access to the machine. So port 20 from my IP. Okay, and let's keep the default outbound rule so that it should be able to reach the load balancer and so on. So let's keep it the way it is and hit create security group. So that's one done, two more to go. Okay, let's create another security group for worker security group. Now worker don't need uh, all the security groups for control plane, but it need for kubeproxy, kubelet, and for the services that will be running, right? So for that, let's go to workers security group. Okay, and let's change the VPC to our demo VPC, create add rule, and then start with 10256, which is for kubeproxy. Source is 10.0.0.16 kubeproxy. Okay, the next one is kubelet, right? The kubelet run on 10250 in the same, and kubelet. The third one is, so we have kubelet, kubeproxy, and yeah, third one is the port range for services. So 30,000 to 32767. This is the range for the node port services, in which like it acquires any of the available ports between this range, right? So yeah, so let's give 10.0.0.16 node port service. And finally the SSH access, SSH from my IP. Okay, this is also done, hit create. Okay, the last one, which is for the load balancer. Security group, create security group. Let's call it LBSG. Load balancer security group. Okay, change the VPC, add the inbound rule. Now, this should be accessible, like the load balancer IP should be accessible publicly to anyone who has access to the cluster. So that's why we can use 6443, and let's keep it open. Okay, and then add an SSH rule as well for my IP. Yeah, for the load balancer, we only need these two rules. All right, so we have created all the security group. Now we need to create the virtual machines, which is EC2 servers. So let's search EC2. We'll start with the load balancer machine. So go to instances, launch instances, let's call it LB. Okay, we'll use Ubuntu image, and the load balancer will need at least one CPU and 2 GB of RAM. So one CPU, 2 GB, T2 small would work fine. Make sure your control plane is greater than T2 small. T2 medium will work for the control plane, but for worker nodes and for this load balancer, this should be sufficient T2 small. Okay, let's select a key pair. I have this one, and make sure you have auto assigned public IP enabled. Otherwise, you will face issue with doing SSH to the server. Let's select the, okay, let's first edit this to change the VPC. Okay, and then you can choose the subnet. We have multiple subnets, so that even if there is a region, a zone failure, for example US West 1B, if the zone is failed, we still have the nodes running in another availability zone. So that's, it provides you high availability. Okay, and auto assign public IP enable. Then select existing group, and this is load balancer, so we'll select the load balancer SG. Okay, and 10 GB of storage should be fine. I think it will work fine with 8, but for the safer side, let's keep it 10. Okay, yeah, that should be it. Hit launch instances. While it is provisioning the instance, let's create the other ones. So let's create worker, and let's select the number of instances as 2, because we need identical instances, right? So this will work fine. So Ubuntu, and then yeah, worker as well, T2 small will work. Now key pair, select the key pair, hit edit network settings, select the VPC, and you can select any of the available subnet. Auto assign public IP, select existing security group, and then worker SG. Okay, let's use 10 GB of memory and hit launch. Now it will launch 2 instances for worker. Let's hit refresh. Yeah, so let's create for master as well. Master, and again number of instances should be 2. Now Ubuntu instance type. Now this time make sure you use the instance type at least T2 medium. Then key pair, and edit the network settings. CK demo VPC auto assign public IP, select existing security group, and security group is master. Okay, 10, hit launch. Okay, now our instances have been launched. We have created the instances. Okay, now let's start with configuring the load balancer. So I'm going to click on load balancer, hit connect, and I'll copy this command from here. I'm going to open the terminal. Now I'm in my Mac, so this is the default terminal. A lot of people have asked me which terminal I was using earlier. So this is the default Mac terminal, but if you are on Windows, you can use Git Bash, you can run it on VS Code, or you have Putty. There are many other options, Mobax term, Super Putty, many options. You can choose whatever you like. Okay, so where am I? My So let's go to downloads. Okay, and I'm gonna run the SSH command from there because I have my key over there. Okay, I'm inside the load balancer virtual machine. As you can see, let's clear the screen. I hope the font is not too small, but let me try to increase it. Okay, now first step is let's do sudo for elevated privileges so that I could do all the changes. Now to make sure that I run the command on correct terminal, let's just give this terminal a prompt. So ps1 is equal to lb. This is the load balancer machine. Okay, so now I'll be running some commands that I have, like all the commands, all the instructions are there in the GitHub repo, so you can copy it from there. First I'll do a sudo apt-get update and upgrade so that it will have the latest packages, and then I'm going to install ha proxy. This is the load balancer machine, right? Okay, let me pause it while it is doing the installation. Okay, this is done. It should show you that if it is done, like we won't see any error. So let's run the command to install ha proxy. Sudo apt-get install ha proxy. Okay, and then after that I'm gonna edit the file for ha proxy, which is this one, etc ha proxy.cfg. Okay, can go at the last line with shift G and then shift A to the end of the line. And now let me just, yeah, this is better. So we'll add the front end, this one. Okay, what it will do is, let me just explain it to you. So there is this front end Kubernetes API. What it will do, so this is the front end name. You can give any name you want, but this is, it's an identifier. Okay, it helps with the readability that yes, this is the front end for Kubernetes API. And um, port 6443 is a standard Kubernetes API port on which the API is exposed. Then we are providing the that it will be using TCP mode, okay, and default backend Kubernetes master. That means any connection that it will receive, okay, that means any connection that it will receive, it will go to the default backend, this Kubernetes master node. So we'll provide those details as well. Okay, and then what do you have? Yeah, we have to provide the backend details as well. So I'm gonna copy the code for backend. Okay, so this is the backend code, again backend, and then we'll provide an identifier, mode, TCP balance, round robin, like how the Kubernetes load balancer, like this ha proxy will balance the load among multiple backends. Okay, so it will use the round robin algorithm. Then it have some options, so you can read about those. I have provided the details in the GitHub repository. Okay, you need to make changes over here. So we need to provide the private IP of the master node over here and the private IP of master node 2 over here. So this is so that whatever request this receive, it will redirect it to one of those control plane nodes. Okay, so let's go back, go to instances, and we have, let's give this a name, master 1 and then master 2. Okay, so master 1, which is this one, let's copy the private IP address, and I'm gonna make the changes over here. All right, and let's go back to master 2. Let's copy the private IP and we can make the changes over here. Okay, let's save this file. And now what we need to do is we need to restart the ha proxy service. Okay, so let me just copy the command. So you can use systemctl command, I believe, sudo systemctl restart ha proxy, because ha proxy has been installed as a systemctl service. Oops, system system. Okay. Now sudo systemctl. Oh, okay. Now it will give you this message that no server available. Master node has no server available because we have not configured anything on those servers, right? So that is fine. So systemctl enable HA proxy so that it will persist, it will restart the service on the node reboot as well. Okay, so this is done. Let's clear the screen. Now we can just check if it is listening on port 6443, it is ready to accept the incoming connection or not. Okay, so nc-v localhost and on the port 6443. Okay, if it is configured fine, then you will see something like this: connection to localhost succeeded. Okay, so our load balancer has been configured. Now let's log into the master node. Okay, I will keep this window open. I'm gonna create a new tab. Okay, and let's go back over here on master one. So we'll be configuring the leader master node first. So hit connect, and then I'm gonna copy the command from here. Yes, sudo -i, and then let's just add master one on the prompt. Okay, now we'll start with disabling the swap. So I've just copied the command. Let's disable it, and then we'll update some kernel parameter to forward IPv4 traffic and configuring the IP tables to see the bridge traffic. Okay, so these are the command. It's like basically these are the parameters that we are updating with sudo systemctl. We are applying the system parameters without the reboot, and this is just verifying it. Okay, so it's done. Now let's proceed the next step. Next step is to install container runtime. I've copied the command and I'm gonna paste it over here. So it is downloading the package version 1.7.14 of container runtime. Container D is the container runtime that we are installing, and it is making certain changes like changing the directory, changing the file permissions. Oh, no, not the file permission, but it is um, just making some configuration changes and then restarting the service and checking the status of it. So if you run the command, if everything is fine, then you will see your container D service is running. Okay, let's exit with uh, q like colon q, and then the next step is to install runc. Runc is not part of container runtime, so we need to install it explicitly, and this is also done. Now we need to install CNI plugin. I'm just fast forwarding this step because this is documented, as well as we have configured this in day 27 video as well. Next step to install the packages for kubeadm, kubectl, and kubelet. Okay, so this is the command. Okay, now you can, like, once this is done, you can check the kubelet status. So let it complete. Let me just pause the recording for now. Okay, it has installed all the packages, and these are the versions. So 1.33 kubelet, and then kubeadm. Then we need to like, let's check the kubelet status. Systemctl status kubelet. Okay, it says the loaded. Oh, it says inactive. It is dead. Maybe because we have not initialized the control plane, maybe that's why. But let's check the logs. So journal ctl -u kubelet. Okay, no entries. I believe the command is correct. Yeah, maybe it has not populated it yet, but let's initialize the control plane and then we'll check if it is working fine or not. Kubelet. version hyphen hyphen client kubelet version or just kubelet version. Okay, 1.33. Yeah. Okay. So let's initialize the control plane master node. Okay. So this is the command. Um, with the earlier command in day 27, when we had a single control plane node, we did not provided this particular option like control plane endpoint because we had only one endpoint, which is the private IP of this node. But now we have to provide over here the load balancer private IP. And over here, we need to provide private IP of this particular instance, which will act as the leader master. Okay, so let's get the details from here. Leader master private IP, this is the one. And the load balancer private IP is this one. Okay, I'm gonna add it over here. Okay, then hit enter to initialize the control plane. Okay, then it will generate the command, the join command for you. So make sure you save it and keep it handy because we need those token to be executed from other nodes. Okay, so let's see. Now it says, starting the kubelet, writing the kubelet configuration file. Earlier it was not healthy. Now waiting for kubelet health status. And then over here it says kubelet is healthy after 501 milliseconds or microseconds. Okay, so this is done. Now we can run these commands to configure the kubeconfig. And this is the command that I was talking about. So it says you can join any number of control plane by running this command over here. So this is to join the control plane node, and over here then you can join any number of worker by running these commands. Okay, so it has generated two token commands for you. So let me copy this and I'm gonna save it to a notepad, text edit, whatever you have. Let's create a new document. Okay, we'll use it later on. Okay, for now let's run this command, and now we should be able to run kubectl get nodes. Okay, so kubectl get nodes is working. The node is not ready because we have not installed uh, a network plugin such as Calico. So that's what we're going to do now. We need to install Calico or Cilium or whichever plugin you are using. So this is the command kubectl create. I'm using Calico version 3.280 with the help of the operator. There is a trigger operator for that. It will apply all the CRDs and CRs. So this should be done. And once all the pods of Calico are up, then you will see a node will become ready. So let's just check kubectl get nodes. Still not ready. Let's check the status of pods kubectl get pods hyphen a for the other. So it's there are few pods that are coming up: Calico kube control, Calico node, and then CSI node driver, and then there is core DNS. So let's just wait. Let me just add it to watch so that we see the update in the real time. So we have two more pods in container creating. There is one pending. This is done. This is done. What else? I think we have everything is up now. Clear up, clear, and then get pods hyphen a. Okay, all the pods are up except this one Calico node, but yeah, this is up as well now. So if you do kubectl get nodes, oops, kubectl get nodes. Okay, the node is ready, and this is our control plane node. So the first master has been configured. If you have done till here, kudos to you. If you haven't, You can do that, right? That's You can just follow the steps along. You can watch the video from beginning again, or you can follow the step in the GitHub repo. Okay, let's proceed further. Let's log into the other control plane node. So I'm gonna go to the master 2 node this time, hit connect. Okay, and let's copy this. Let's go to terminal. I'm gonna open a new tab again and run the ssh command. Yes, clear sudo I, and then ps1 equal to master 2. All right, now for the master 2 as well, we'll start with disabling swap. Oh, where is my cursor? Okay, over here, and then changing the kernel parameters. Then same steps. Okay, it except the kubeadm init. We'll go till there, and then I'll show you what needs to be done. So this is to install container runtime. Then after container runtime, run C. This is running. So let's exit this and install run C. Then CNI plugin. Okay. And after that, install the utilities, kubeadm, kubelet, kubectl. Now kubelet will not be up until we join the node to the master. Okay. So once this is done, we'll go to this command, which is for the master join. Okay. So I'm going to run this command after this. Yeah, I should have paused the recording over here. It's taking some time and you might be just watching the screen. But while it is doing, you can like the video or comment on it. How are you liking it so far? Okay, let's run the command to join the master node. Okay, now this will also start the kubelet on this machine. So we have our load balancer over here. This is master 1, this is master 2, and master 1 is the leader master. Okay, it will generate the certificates. You will see some failure messages because it will check some health checks, and uh, after that it will be okay. So now it says waiting for the kubelet to perform the TLS bootstrap of this node. This is done. Okay, now you can run these commands over here to run the kubectl commands. So oops, oh, come on, kubectl get nodes. Okay, now we have two control plane nodes, both in ready status. This is just like what we just started. Okay, now our load balancer is done, both the control plane nodes are done. The next step is for the worker nodes. So again, let's go back to the control plane machine, sorry, EC2 control plane, EC2 instances. Go to worker, let's give the name worker 1, and I'm gonna connect, copy it, and go back, shell, new tab, and run the ssh command. Yes. Okay, and then sudo I. Let's give this a prompt, ts1 equal to worker 1. Okay, now we'll start with the step to disable swap, and then kernel parameter, all the things that we did for the worker node. It just the join token will be different for the worker node. Okay, and this is for container runtime. After that is done, we'll install run C. Okay, after run C, we'll install CNI plugin. And then we'll install the utilities, kubeadm, kubelet, kubectl. And then we'll use the join token command. So I'm gonna go to the work. Okay, this one. So the second command, which says then you can join any number of worker nodes by running following as root. Okay, we have already elevated the privilege using sudo I, so we don't need to log in using root. It's kind of one and the same thing. We just needed the privilege to execute those commands. Okay, it's almost done. Okay, now it says client version. This is the kubelet version. It installed. Now let's run the join command. Okay, this was fast because this is just the worker node. Let's go back to the master node over here. Master 1 or master 2, anything would work. So this is master 1. Get nodes, and we see the node is not ready. Oh, it's ready now. It was just coming up. So it's ready. Now we have two control plane, one worker node. Now we need to perform the same step in worker node 2. Okay, so let's do that. We have done so far, so why don't we just finish this? Oh, you have been signed out. Why I have signed out, I don't know. Okay, not this one. Okay, let me pause it while I'll do the sign in. Okay, I have signed in, and let's go to the last worker, which is this one. Hit connect. Copy the SSH command. Let's go to terminal. Open the new terminal tab. SSH. Yes. And sudo -i. Okay, let's give this a prompt. Worker 2. Clear the screen. Okay, now let's execute the steps again. Let me just copy it from my document. Disable swap, kernel parameter changes, then install container runtime, then install run C, and install CNI plugin, and install kubeadm, kubectl, kubelet, blah blah blah. Okay. This should be done, and then the last step is just to run the join command. So let's do that. Okay, this one over here. Almost done. Almost done. I know you must be losing your patience by now. It's kind of a long video and complete hands-on, but this is what it is. Okay. Join. Okay. Should be done. Now let's run get nodes again. Now we should have 4 nodes. Not ready, not ready, not ready, not ready, not ready. It should be ready soon. So ready. Okay, so we have two control plane and two worker nodes and one load balancer. Now let's check if a load balancer is working fine or not. So we can check the load balancer logs from here. So journal ctl-u ha proxy, and we can just tail the logs. So you see it is basically logging all the requests on different ports, and master 1, master 2, all the, like, it is redirecting the request to one of those nodes, right? So that's good. Now let's just maybe run a simple command to see if we are able to schedule a pod or not. Kubectl run nginx hyphen hyphen image is equal to nginx. Kubectl get pods, container creating, container running, and you can check on which node it is running. Hyphen o wide. It says 10 0 23 107, and if I do kubectl get nodes, 107 is this one, which is one of the worker nodes. Okay, so I think this is done now. Like, there are some additional step I have shared in the GitHub repo. So you can copy the admin.conf file from the control plane node to your local machine, and then you can basically run the kubectl command from your local machine if you want, without even doing the SSH in one of the master nodes. Okay, let me show you. It's just matter of few seconds, so it's fine. Why not? I hope you are there till now. If you are there, you are awesome. Thank you so much. Okay, so cat etc kubernetes admin.conf. Okay, so there'll be a big kube config kind of file. I'm just gonna copy it, and let's open a new tab, and this time I'm not gonna do the SSH. Okay, I'll just vi kube config. Okay, and we need to make one more change, I guess. Okay, okay, kubeconfig.yaml. Okay, what we need to change is we need to change the server URL. Okay, so over here where you see the IP, we need to replace it with the private IP of load balancer. So let's go to instances, load balancer, private IP is this one. Let's make the change. Okay, now you can run, or you can, yeah, provide kubeconfig is equal to this file, which is kubeconfig.yaml. Okay, kubeconfig.yaml, and then you can just run kubectl get nodes. Network is unreachable. Why? HA prox. Oh, no. Sorry. We need to provide the public IP, not the private IP over here. Public IP of the load balancer. Let's make the change again. Kubeconfig YAML. Okay, let's run the command again. No, it says unable to connect. Oh, why is that so? Control plane private IP. Let's check. Server. Mm. Okay, I would need to perform some troubleshooting for that, but I hope you were able to do it. Maybe I did some mistake. I don't know what did I do. Um, but this is working fine from any of the master node. This should work from here as well. but I don't want to drag this video further. This is the last step, and I'm sure you will be able to do the troubleshooting by yourself. If you're not able to do, let me know in the comments, or you can reach out to us in from our Discord community as well. We have a wonderful Discord community. There are a lot of people who are there to help you. Link will be there in the description. You can join the community and you can share the details. Any error that you are facing in any of the videos, they are super supportive to help you out, and I'm also pretty active in that. um yeah, I guess that's it then. Yep. So this video went on to like 55 minutes. So thank you so much for your patience so far. And this brings us to the end of the CK series. I hope you had a wonderful learning experience. If you did, make sure you do the hands-on of all the videos in the series. Most of them are the actual exam question, exam tasks. And if you do the hands-on, you will be saving a lot of time in the exam. Plus, you will know what to do when you face an issue, especially the troubleshooting tasks. So yeah, that's it. Have a good day and have a good learning experience. Share it with your friends, colleagues, whoever you can. And that's it. I will see you soon with the next video because learning never stops. Thank you so much.